Hello folks, we are going to talk about Internet Protocol. The Internet Protocol is an extremely important portion of the TCP/IP protocol stack because it is what determines where your traffic is going to be routed. And it does this based on the destination address. Now the Internet Protocol does operate at layer 3 of the OSI model, and it would be considered layer 2 of the TCP/IP protocol stack, the Internet layer. It is connectionless protocol, and that characteristics mean that traffic is sent one way and it is sent without notifying the destination device in advance. The destination device is going to get that data, and he is not going to reply back and say, hey, I got this. We are going to leave that up to the TCP protocol. If the connection is deemed to be reliable, so IP doesn't worry about any sequence and acknowledgement of the datagram that it sends. Now IP uses a hierarchical addressing. It is a 32-bit number. Part of this number is what we call a network ID, and the other part of that number is the host ID that we will talk in our next lecture about the network addressing, IP addressing. Now the network portion is kind of like a street that you live on. If you are considering an address, the host ID portion of the address is the house number. Having a separation like this allows you to route traffic toward a street, and then once we get to that street, be more specific and find the house. In networking terms, we would route traffic towards a network. Once we are on the network, we look for a specific host. The service that IP provides is best efforts. It doesn't guarantee that the packet will be delivered. A packet would be dropped along the way. It could be duplicated along the way. It could be routed in the wrong direction. Again, IP does not provide any reliable service. Instead, if we need reliability, we are going to leave that up to our upper layer protocol, for example, TCP in this case. Recall that we said that traffic that is passed down the protocol stack receives a header, and the header contains information that is relevant to that layer, and it is used for providing service to the layer above. It is important to understand the IP header format because attacker can manipulate those fields in an IP header and use that as an attack vector. So as an analyst, you definitely want to be familiar with the different field inside of an IP header. In this graphic, we do see an IP header with a number of different fields. We will go through each of these fields, just explaining what they do. The first field we have is a version field. The version field is a 4-bit field, and it tell me that version of IP is being used. For example, IP version 4 or IP version 6. The next field we have is deemed HL or IP header length. IP header length or IHL. This also is a 4-bit field, and it contains the length of the entire IP header. This minimum length for an IP header is 20 bytes. 4, 3, 7, 2, 9 and 1, 8 bytes here. So the IHL field tells you how many bytes are in the total header, but this will tell you the specific header, a specific field data length. So IHL is talking about the whole length of header. The next field we have is deemed IHL, as we talked. So you can see in this graphic we have the first two fields, which are a 4-bit fields. Those two fields combined together equal 1 byte or 8 bits. This is 1 byte, and this is 2 byte, and the byte 3 and byte 4. This contains 4 bytes. So the next field we have is the service type. We call this the TOS, a type of service field. This is an 8-bit field, and in traditional networking we use these three of these bits, or what's called an IP precedence value. IP precedence value can be used IP precedence value can be used for providing quality of service. Nowadays we use differentiated service code points, which is 6 bits of that field, which the remaining 2 bits used for explicit congestion notification. Using DSCP rather than IP precedence provide for large number of differentiation between packets, allowing you to provide different level of service. The next field we have is the packet length. Now this is the entire length of the packet. It includes the 20-byte IP header, as well as all of the user data that is encapsulated inside here. This field is 2 byte long, and the maximum size that we could ever seen an IP packet being would be 65,535 bytes. How many? 65,535 bytes. This is followed by identification field, the flag field, and the frag offset field, fragment of offset field. So the next field we have is the packet length. Oops. The next field we have is the packet length. Now this is the entire length of the packet. We talk about this. So when we are passing an IP packet throughout our network, it might go through different devices that can handle the size of packet, in which case the packet will need to be fragmented. And if the packet need to be fragmented, it is divided into a smaller chunks, and each of these chunks can then be collected and reassembled at a later time. We use these three fields to mark the packets, identifying them as a fragments, and then we use the information, the identification flag and fragment offsets. The next field is the time to live field. The time to live field, or TTL as it is called for short, is used to make sure that this packet does not move through the network endlessly. If there is a routing loop, that potentially a packet could be sent back and forth over and over again. And without the use of time to live field, the packet would never be discarded and it would be forwarded forever. So the TTL field is a value that decrement at each layer 3 hop. It is initially set to a number. Sometimes this number will be 30, and each hop we will decrement that by 1. And once the TTL value reaches 0, the packet can be discarded. And this is the field that we can control in some implementation. And we can also find out by giving the dig command on command prompt on window. The next field we have is the protocol field. This field determines what kind of application layer data is being used. So for example, if we are using protocol number 1, that would indicate that this is an ICMP packet, and the ICMP protocol is being used. We use ICMP for testing connectivity and so for relating errors and for control management. This protocol field is often set to a value of 6, which indicates that upper layer protocol is TCP, or protocol 17, which indicates that the upper layer protocol is UDP. So we talk about 3: ICMP, UDP, and TCP. ICMP indicated by 1, TCP indicated by 6, number 6, and UDP indicated by 17. Correct. That's followed by a header checksum. The header checksum is just a value that gets calculated based on the content of the header itself. Whatever the contents of the header is, it's based on them. This is used to determine if there's been an error while this packet has been forwarded. The two fields that follow the header checksum is source address and destination address. The source IP address, which is the 32-bit identifier of the sender, followed by the destination IP address, which is the 32-bit IP address of the recipient. In standard IP routing, routers are going to reference the destination address field. In source-based routing, router would reference the source address field. These two fields are followed by the option and padding field. This is a field that varies in length from 0 to some multiple of 32 bits. And if the option values are not a multiple of 32 bit, we are going to pad that with the number of zeros so that we can make sure that the header itself meets the minimum 20 byte size. So this is all about from IP protocol. So next we are going to talk about IP addressing. So see you in next lecture.